Helicopters weren't supposed to go this fast. There's a hard ceiling in rotorcraft physics, around 200 knots, where retreating blade stall and advancing blade drag start tearing performance apart. Sikorsky didn't work around that ceiling. They broke it. Traditional helicopters face a brutal aerodynamic problem at high speed. As the rotor spins, one blade moves forward into the airflow, advancing blade, and the opposite blade moves backward, retreating blade. The faster you go, the more lift imbalance you create. Eventually, the retreating blade stalls, and that's where conventional helicopter speed hits its limit. That limit has haunted rotorcraft design for decades. The Raider X, built on Sikorsky's X2 coaxial rotor technology, attacks the problem directly. Instead of one main rotor and a tail rotor, Raider X uses dual, counter-rotating coaxial rotors mounted on the same axis. Both rotors generate lift and cancel torque without the need for a tail rotor. That alone changes the stability equation. But here's where it gets aggressive. Raider X adds a rear-mounted pusher propeller. Instead of the rotor system being responsible for both lift and forward thrust, the pusher prop handles high-speed forward acceleration. The rotors primarily maintain lift and stability. That separation of duties is critical. By offloading thrust from the main rotor system, the aircraft reduces retreating blade stall limitations and pushes far beyond traditional speed constraints. Sikorsky's X2 demonstrator exceeded 250 knots, a serious jump beyond legacy helicopters. But speed isn't the only gain. Coaxial rotors increase lift efficiency and eliminate the power loss normally consumed by a tail rotor. In conventional designs, up to 10 to 15% of engine power is diverted to counter torque. Raider X reclaims that energy for lift and forward performance. That's not aesthetic innovation. That's physics-level optimization. There are trade-offs. Coaxial rotor hubs are mechanically complex. Dual rotor systems increase gearbox demands and structural loads. Vibration management becomes a critical engineering challenge. Blade phasing, torque balancing, and mass design must withstand intense stress. This isn't simple engineering. It's controlled mechanical aggression. Raider X also integrates fly-by-wire controls and advanced vibration dampening systems to stabilize the inherently more dynamic rotor environment. The aircraft isn't just fast, it's digitally stabilized to manage forces that would overwhelm older control systems. The airframe itself is compact and optimized for agility. Built to compete in the U.S. Army's Future Attack Reconnaissance Aircraft (FARA) program. High-speed dash capability combined with maneuverability gives it a hybrid identity. Part helicopter, part high-speed rotorcraft experiment. But here's the deeper shift. Traditional helicopters accept aerodynamic compromise. Raider X challenges it. By splitting lift and thrust functions and using counter-rotating rotors, Sikorsky reshapes how rotorcraft operate at high speeds. It's not just faster, it's mechanically different. And if coaxial plus pusher designs prove scalable, conventional single-main rotor helicopters may start looking like transitional technology. For decades, helicopters were boxed in by physics. Raider X doesn't ignore those limits. It engineers around them. And when aircraft start bending the rules that defined them for 70 years, you're not looking at an upgrade. You're looking at a category shift.